Okay, so this is a video just on fractional indices for a student of mine. First thing to talk about is just some basic surds revision. So if I give you the problem root 27, okay, this symbol here is a square root symbol, like a square root sign. What we can do is write a 2 there if we want to represent the fact that we're square rooting this, but in practice we don't, because it's just an extra number that we don't want to write. Okay, I can write root 27 as the square root of 9 times 3. Okay, because 9 is a square number, I can rewrite 9 as 3 squared. So 3 squared times 3. Because 3 is that square, because 9 is 3 squared, okay, I can take that, I can square root that 3 squared, and it just becomes 3. Okay, so I can write root 27 as 3 root 3. Okay, so another thing to think about is, well, I can have more than just square roots. I can have cube roots, okay? So if I have the cube root of 81, I can say, well, okay, what cube numbers go into 81? What numbers to the power of 3? Well, I know that 81 is equal to 9 times 9. 81 is a square number, okay? But I can rewrite 9 times 9 as 3 squared times 3 squared, okay? Or I can rewrite that as 3 times 3 times 3 times 3, okay? Another way of writing that would be this. It would be 3 cubed times 3, okay? So because, just going to erase this here, because now this should be I should have 3 there, sorry, because this is a cube root. I'm just going to make sure the 3 is out the front in black. So the cube root of 81 is equal to 9 times 9, and I can rewrite 9 times 9. I can rewrite 81 as 3 cubed times 3. Okay, so now I can see here, well, there's a cubed number, so I can cube root that, and the 3 will come out the front. And so the cube root of 81 is the same thing as writing 3 cube root 3. Okay. And the thing is, you can keep going with this. You can keep going all the way up to any number, any root. So for instance, if I have the 4th root of 32, okay, I can rewrite the 4th root of 32 as, I can rewrite 32 as 16 times 2, okay, because 2 16s are 32. Now I can rewrite 16 as 2 to the power of 4, because it's 2 times 2 times 2 times 2 times 2, okay? Now, I can see that 16 is 2 to the power of 4, so because this is to the power of 4, I can take that out the front because it's the 4th root, and I can rewrite that as 2 4th root 2. So that the 4th root of 32 is 2 4th root 2. Okay, so hopefully that's clicking in your head and that's making sense. Okay, because if it doesn't, this next stuff is probably going to be pretty tricky. Let's look at this question here. Okay, I think I've already gone over it with a few people before. But in this question here, I've got 16x to the power of 2/5 to the power of 1/4. Okay, so this means I multiply everything inside, each term inside the bracket by to the power of a quarter. So that's 16 to the power of 1 times a quarter, so that will give me 16 to the power of a quarter, times x to the power of 2/5 times a quarter. So that will give me 2/20, and that will simplify that fraction over the x will simplify to x to the power of 1/10. Okay, so this is as simple as it gets, but this here can be simplified further. Okay, remember, if you have a fractional indice, okay, let's say it's x to the power of 2/3, I can rewrite that as the cube root of x squared. Okay, so the number down the bottom of the fractional indice is the root part, and the number up the top is the power of x. Okay, so for instance, if I had x to the power of a over y, okay, you should be able to stop the video now and go, okay, well that's equal to the square, the y root of x to the power of a, because again, the bit down the bottom is the root, and the bit up the top is the power. Okay, so in this case, I can rewrite 16 to the power of a quarter as the fourth root of 16 x to the power of 1/10. Okay, so these are separate. To make sure I write them as a separate thing. Well, we just saw that before. The fourth root is 16. I can rewrite 16 as 4 to the power of 2. Sorry, 2 to the power of 4 times x to the power of 1/10. And because it's the fourth root of something to the power of 4, that just becomes 2x to the power of 1/10. Okay, those things cancel out, and you're just left with 2. Okay, let's just do one more. Let's do C. Okay, so 27 x to the power of 3/8 all to the power of 2/3. Okay, so this is 27 to the power of 1. So I'm going to multiply my indices. So 27 to the power of 2/3, because 1 times 2/3 is 2/3. X to the power of 3/8 times 2/3. Okay, so let's just do that arithmetic. 3 times 2 is 6 at the top. 3 times 8 is 24. 6 goes into 24 4 times, so this will become 1/4, I believe, if I'm doing my sums right. Okay, so that's this bit here is as simple as it gets. Okay, I can't simplify that anymore, but this bit here, well, I can see that if I want to, I can rewrite that 27 as the cube root of 27 squared. Okay, or another way of writing that would be I'm going to rewrite that. Okay, the cube root of 27 all to the power of 2. Okay, it doesn't matter if I do the cube root first and then the squared, or vice versa, but that's what it's equal to. So the cube root of 27, well, I know that 27 is equal to 3 to the power of 3. Okay, so that's just like saying the cube root of 3 to the power of 3, and that's just 3. So I can rewrite this bit here as 3, as per up here. And 3 to the power of 2 is just 9, because that's just 3 squared, so that's 9. So I can rewrite this 27 to the power of 2/3 as 9, x to the power of 1/4. Okay, so these things certainly take practice, just trial and error. Make sure when you're making mistakes, you're reasoning through why is that wrong, and if you keep at it, you'll get it eventually. Thank you.